Hello, my name is Keith Davis. I am president of KLJ Instruments. In a previous presentation, I programmed the SQTR-2M to transmit an ADSB target in the synchronous interference mode. Today I will demonstrate how to add interference to the scenario. But I want to start by examining the various files created by the SQTR-2M. Once I have described the file type, we will focus on the log files so we can compare that information to the information presented by the radar cape ADSB receiver. When a compiled scenario is saved, three types of files are created. The first is a text file. In the previous video, we chose to name the name S1 target. I was prompted to enter a brief description of the scenario file that is stored in this file. The second type of files are scenario files with the .scn extension. These files contain the commands that are executed by the SQTR-2M hardware and are automatically created by the SQTR-2M. One scenario file is created for each active channel. The file name of the text file is appended with an underscore and the channel number and the SCN extension. The third type of files are log files with the .csv extension. As with the scenario files, one log file is automatically created for each active channel, and the file name of the text file is appended with an underscore, the channel number, and the CSV extension. It is important not to confuse the log files with the GUI file. Each scenario has only one GUI file, and the GUI file can be saved with any name and extension that you choose. However, we recommend that you use the same name in the CSV extension for the GUI file. The key difference is that the log files have the channel number appended to the name, but the GUI file name will not have any text appended. Now that we have looked at all the file types, I want to focus on the log files. These files can be opened with a text editor or with spreadsheet software such as Excel. For simplicity, I will open s1target_0.csv with Notepad. You will see that the first line contains the column headers for the information in the file. The data in this file have a variety of uses when analyzing the performance of an ADSB receiver. However, for this simple demonstration, I am concerned with the first column, message number. This column tells us that 126 ADSB signals are transmitted by the SQTR-2M during the S1 target scenario. When we compare this value to the trust value from the radar cape screen, we find they are equal. This indicates that the radar cape received all of the target signals. When we run signals with interference, we will compare these two values to determine if the interference is preventing any ADSB signals from being decoded by the radar cape receiver. Note also that the radar cape tracked the SQTR-2M target for 6 tracks. These tracks are each 5 seconds long, so the total equals the 30 seconds. This matches the scenario length that is programmed into the SQTR-2M. I will start the SQTR-2M software and select synchronous interference from the main menu. In the last video, I demonstrated how to save the GUI and scenario files. This time, I will read the s1target.csv GUI file into memory as a starting point. I will move the interference select slider to the sync position and then select Sync Setup to display the Synchronous Interference Setup menu. Moving to Target Setup, we can see the target parameters that I programmed last time. Note that each channel may be enabled or disabled and that the timing, frequency, and RF levels for each channel may be set to change randomly between minimum and maximum values. If the minimum and maximum values are equal, that parameter will be a constant value. I will enable channel 1 and set the minimum and maximum timing to -100 and +100 microseconds. I will set the RF level to be the same as the target at -50 dBm and the interference type to I will also set the average number of at-crabs pulses to 8. I I will compile this scenario, then exit to the Test Setup menu and save this scenario as S1 Target Random at Crabs Garble. As the scenario runs, we can see the target messages from the Channel 0 video of the SQTR-2M and the at crabs messages from Channel 1 of the SQTR-2M on the oscilloscope. Now let's look at the results. The S1 Target Random at Crabs _0.csv log file shows 125 messages. When the radar cape receives this scenario, it receives 121 messages, so the at crabs interference caused the loss of 4 messages. Let's add more interference. I will enable channel 2, program the timing to vary randomly from -120 to +120 microseconds, set the RF level to change randomly between -70 and -50 dBm, and select long mode S as the type. I will save this scenario as S1 Target Random Mode S Garble.csv. We can see the SQTR-2M Channel 2 Mode S signal on Channel 3 of the oscilloscope. The results show that the SQTR-2M transmitted 127 messages and the radar cape received only 90 messages. So the added interference caused a total of 37 messages to be undecodable. Finally, I will enable Channel 3, fix the timing at -50 microseconds, vary the RF level randomly between -60 and -40 dBm, and set the type to be short mode S. We can see the SQTR-2M Channel 3 signal on Channel 4 of the oscilloscope. The results show that the SQTR-2M transmitted 127 messages and the radar cape received only 17 messages. So the added interference caused a total of 110 messages to be undecodable. This concludes this demonstration of a target and interference in the synchronous interference mode. Thank you for watching. In the next video, I will demonstrate the asynchronous interference mode of operation.